Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Engineering. So in this session, I am going to discuss about the losses in optical fiber. The another name for losses is nothing but attenuation. So losses means when light propagates through an optical fiber, a small percentage of light can be lost through the different mechanisms. So there can be the loss of data. So it is called as the attenuation. So the attenuation can be defined as the ratio of output power to the input power. So likewise we can calculate. So the following attenuation mechanisms can be considered in designing the optical fibers. So that are absorption, scattering and radiative losses. So first if we see the absorption means, so usually the absorption of light can be occurs due to the imperfection of atoms. That is missing of molecules can be there, and hydroxyl ions and high density cluster of atoms, so that will absorb the light. Due to that absorption there may be the loss in the data. So absorption also depends on the wavelength of the light used. Okay, and if we go with scattering, so it is associated with the fiber material and with the structural imperfection in the optical wavelength. So it is also wavelength dependent loss, so which occurs inside the fiber. So if light is passes through the atoms in the fiber, the portion of light is scattered, and this type of scattering is called Rayleigh scattering. And third one is the radiative loss or bending loss. So here we have two types of losses, that is macroscopic bend and microscopic bend. So macroscopic bend is nothing but the radius of core is large compared to the fiber diameter. It may cause a large curvature. So in macroscopic bending, so the light can escape from the core cladding interface, and in microscopic bending, so the microscopic bending will come from the manufacturing. The minute bends there will be there, or by giving pressure to insert the fiber in a particular location, so the micro bends can be created. So the radius of curvature is increased means we have the macroscopic bending. So how we can how we can minimize these losses means, so we have to we have a compressible jacket over the fiber. So when the external forces are applied, the jacket will be deformed, but the fiber lead to stay straight and safe, so without causing more losses. So likewise we can reduce this. Another dispersion or distortion is nothing but when optical signal is sent to the fiber, the output can be the blurred one and the width can be broadened. So that is called the dispersion. So when light sent into the fiber, the pulse broadens and as it propagates through the fiber. This is called the dispersion. So we have different types of dispersion, that is intermodal dispersion, material dispersion, and then waveguide dispersion, polarization mode dispersion. Intermodal dispersion will occur while propagating through the fiber. So it will have a different dispersion for a different wavelength. So if we go with material dispersion, it is occurs due to the different types of material. The wavelength of the material can be changed. And then waveguide dispersion, so this is arised due to the guiding property of the fiber. So so that will be the light can be entered into the different angle and incident at core cladding interface. So the polarization mode, the wave guide will be the birefringent. So these are the different types of dispersion. Due to this, the light can be broader in the output. So thank you.